You. So welcome back to the series on Noodle Chopsticks, and we have already discussed that what the series is about. Basically, if you have a problem on hand, there are two ways to solve it. One is this noodle method, and one is this chopstick method. And I personally prefer this chopstick method, obviously, because the noodle method is so confusing, it is lengthy, it is error prone, and it is difficult to grasp. But still, some teachers use it, and I always think maybe because they learned it that way and they don't know there is a chopstick method out there, or maybe they know there is a chopstick method but they want to confuse you and show that it's one of the most difficult topics, and had you not come to me you would have never understood. So whatever it is, we are going to stick to the chopstick method. And my name is Bhavdeep Sethi, and I've been converting physics haters into physics lovers. And I always say, learn physics in the nature around you. You don't have to memorize anything, everything is available around you. Textbooks are great, but nature is the best textbook out there. So today we are going to see how chain rule and substitution, they are actually the inverse operations of each other. The problem with our education system or the curriculum is they teach you things in bits and pieces. They don't glue them together. So you study something in motion, then you study something in laws of motion, but they don't glue together. Or maybe things like you study simple harmonic motion, but then you use all those concepts in alternating current. But things are scattered around. They're not taught in a logical, meaningful way. And we are trying to change all that in our series on noodle chopsticks. So you will see how you study chain rule and you study substitution method, but behind the scenes they're actually same. They are doing the same things. It's actually an inverse operation. Like, and we will let's see that. So but before that, before what is differentiation? This is not a calculus class. I'm assuming that you've already taken some classes earlier with me, either on YouTube or in some other sessions, and you know what is differentiation, but this is just a basic pre, or I would say it's just a recap. So basically, if I'm saying what is d by dx of, let's say, x to the power 5, we would say, okay, that is 5 times x to the power 4, right? The slope of the graph is what we are talking about. Similarly, if I were to say what is d by dx of sine of x, we know it is cosine of x. So those are the things we already know. This is just a basic recap. Similarly, what is integration? Integration is inverse operation of the differentiation, obviously, because let's say what is integration of um, x to the power 5, let's say. And I don't know what that is. So I'll say, okay, something has to be put in this box. And what is that something? That something should be such that if I do d by dx of that box, I should end up getting x to the power 5, right? So integration is basically an inverse operation, right? So it's also called anti-derivative, by the way. Many of you might know. So that was derivative. This is anti-derivative. So I need something in this box which will, if differentiated, should be giving me x to the power 5. So I know when I do d by dx of something, the power reduces. So I know there has to be something like x to the power 6, because if I do d by dx of x to the 6, I get something like x to the power 5. So I'm close. But the problem is if I do d by dx of x to the power 6, I end up getting 6 times x to the power 5. So that 6 extra has to be taken care of. And that's why I would say, okay, let me put 1 over 6 x to the power 6. So if I were to take d by dx of that, I'll get 6 x to the power 5, 6 and 6 cross out. So I know the answer to this is x to the power 6 over 6. So you see how the integration and differentiation, they are related. They are inverse operations of each other. So we'll take another example here. So just now we learned that, let's see, we learned just now that d by dx, and we know that, I mean, not learn now. So d by dx of sine of x is cosine of x, or you call it cos of x. Now, if I were to do integration of cos of x with respect to dx, so that the variable has to be specified, obviously, with respect to dx, so that should give me what should be the answer. The answer should be such that if I do d by dx of that, I should be getting cos x. So d by dx of what is cos x? D by dx of sine x is cos x. So that's how these are related. differentiation and integration are inverse operations of each other. Now, what is chain rule? Chain rule is a very useful tool in differentiation. Thing goes like this. So let's say I want to find d by dx of sine x squared. Let's say x squared. Now, we are trying to find the derivative with respect to x, but sine, this is not a function of x, it's a function of x squared. So the chain rule says, okay, if sine is a function of another function, you can change this part. And we have done this. If you have not seen this, you see my other videos on this. So chain rule says, okay, you can do this so that now you can find the derivative of sine x squared. Because you see, now this is going to give me cos x squared. But since you change the variable here, it says, okay, you put a link in the chain where you do the derivative with respect to the original variable of the new variable. Now, many teachers actually teach you, okay, what we are doing here is multiplying and dividing by dx square. As soon as you say that, you're actually, I don't know, I don't even have words for those. That beats the whole, the emotions, I would say, of calculus. Calculus is going to be very mad at you. That's not how calculus works. It's not like you're dividing and multiplying. You really have to go into the in-depth of it and see my other videos on that, but never say dividing, multiplying. Okay? Or don't say anything. So now you know this is going to give you cos of x square. Then we have in multiplication d by dx of x square, that gives you 2x. So this is how the chain rule works. You can keep putting more links in that chain. What is substitution method? It's another tool and it's used in integration. So let's say I have to find integration of, let's say, 2x times sine of x square dx. Now you see these are two different functions multiplied here. I don't know if this was integration, of one function, that was easy. But now these are two functions. But then I realize, okay, sine is not a function of x, sine is a function of x squared. But this function x squared, if I find the derivative of that, you have the derivative right here. Only then, and if you realize this thing, then only you can use the substitution method. So differentiation of this is available here. So d by dx of x square is 2x, and that is available here. So if that is the case, you can say, okay, let me take a new variable, which is, let's say, let x square be a new variable u. U is just a convention. You can take anything, like you can take y or whatever. I mean, it's just u. So you say let x square be u, then you find the derivative on both sides. You get 2x dx is equal to du. Right. Now, why are we doing that? Because if you're saying let this be a new variable u, so this is sine u, but now this is all messed up because you have a variable u and then you have variable x. You just want one variable. So what we are doing here is you take this, instead of x square, you put u, but then this 2x dx makes it du. So the thing becomes very simple. This 2x dx is du, good, and then x square is u, so you get sine of u. Now your integration of sine of u is minus cos of u, so you get, this gives me minus cos of u. But u was a temporary variable that we introduced. So we bring back the original thing. So we say, okay, instead of u, you bring back x square. So this is your answer, cos of x square. So integration of this gives me negative of cos x square. So this is called substitution method. I have substituted this x square to be u, and then it works. It becomes easier because see how simplified version this is. So are they related? Yes, they are definitely related. So let's take an example here. So let's take an example where we are saying, okay, let's find d by dx of sine x cubed. If you do d by dx of sine x cubed, you'll say, okay, this is x, this is a cube. So you'll have to do this chain rule thingy where you'll say d by dx cubed of sine x cubed multiplied by d by dx of x cubed. So you get d by dx of x cubed. Now, this gives me cos x cubed. So this gives me cos x cubed, and this gives me 3x squared. So I can write it here, 3x squared. So d by dx of this is this. Good. Now I go into the world of integrations. If I go into the world of integrations, I do integration of, let's say, 3x squared cos of x cubed dx. Should be some box here. That will be my answer. But then you realize that box, if you find a differentiation of that, should give you this. But that box is this sine x cubed, isn't it? So the answer has to be sine x cubed, isn't it? Because whatever is the answer, d by dx of that has to be this. But d by dx of this is this. So the answer has to be sine x cubed. So it's just an inverse operation that we are performing here. So how do we start? Let's say we go by the substitution method. The answer is this, we know that, but we are just trying to see how the substitution method is actually the inverse of the chain rule here. So we see this is x cubed, and we see the derivative of x cubed is 3x squared right there, right over here. So you can say, okay, let this x cubed thing be u. So this x cube is u, so I can write it as cos u, but then I have to take care of other x over here. So then taking derivative both sides, you get 3x squared dx is equal to du. So you take 3x squared dx, you put du there, instead of all this, you put du, and cos x cubes becomes cos u. So this becomes integration of cos u du. Now integration of cos u should be something. If you find the derivative of that thing, you should get cos u. But the derivative of sine u is cos u. So the answer to this is sine u. The u was basically a temporary placeholder for x cubed. So your answer is sine x cubed. Now see, the purpose of this is to teach you how these things are really related. You see how beautifully these are working. The fact that you had this part coming here because of this chain rule, this is where we say, okay, this is coming kind of as a substitution thing now. So this is how you study things which are taught in isolation and try to relate them. Basically, the chain rule and the substitution method, they are actually same things. They are just inverse operations of each other. Now you go back into your textbook and there's a notation f prime, g prime, and all that. And now once you read this, you will be able to relate to that and you will find it very, very easy. So wasn't it so easy? Just tell me. Yes, right? It was very easy. So if you like this video, share it with your friends. I'll explain more concepts soon. By the way, we have launched Full Physics Mastery 2025 course. And what is this course? It's a course for the students who are in grade 9, 10th, and 11th, and they're targeting NSEP 2025 and beyond, and JEE or NEET 2026 and beyond. So these are long-term kind of thing, and also for students who want to fall in love with physics forever. So this course will start in July 2024 till November 2025, where we do the entire 11th, 12th syllabus, which is 100% of NSEP, JEE, NEET syllabus, everything covered over here, 120 plus live classes and also extra classes as and when required. These are the scheduled ones, there are more. And test is going to be every alternate Sunday. And assignment is after every class on the Telegram group. And Telegram group, you can also clear all your doubts. You will be part of a group. You put any doubt there, we'll be clearing it. Students help each other, I help students. And the fee is very less. I mean, class timings will be Monday, Wednesday, about 4:30 to 5:45. And the fees is only 12,500, but there's an offer going on with PHY20, you get 20% off. So you get it for 10,000 rupees only, everything included, no extra fee, nothing, no registration fee, nothing over there. Now you also have an option to purchase it in modules. There are 5 modules that this course has been divided into. So 2,500 each module, because 2,500 times 5 was giving you 12,500. You can enroll in first module and then still get 10% discount with the coupon BS Pro, and all the links are here. Right, everything is in the description, but better. This thing gets better. So maybe you think I'm not ready for a commitment of a long-term batch, or maybe I don't know if I can handle the Olympiad thing along with school, or maybe it's going to be very difficult kind of syllabus here. So you can try this for only 29 rupees. The link is here in the description below. You just enroll for 29 rupees. There's no coupon required. If you click on the link to try it, it says experience course. So if you want to experience it, it's called experience course. The link is there. What you get is 1 week pass of this course. So the course is from July to November next year, July this year to November next year. But for 29 rupees, you'll get 1 week pass. So you can attend the classes for the first week, where I'll be covering what is trigonometry, what is vector algebra. So it's only 29 rupees. You can experience that. It's called experience course. And then you can see if you really think that, you know, some students are skeptical that mere se ho paega, maybe I'll not be able to handle this Olympiad preparation and all. So you try it out. There's nothing to lose. And if you think you can um, proceed in this direction, you can enroll for the whole course after that. So just try it out. Now, the course is divided into 5 modules, as I was saying. The first week is going to cover the mathematical tools. I'll be teaching trigonometry and vector algebra. So the question obviously is, will you be covering the entire trigonometry? No, trigonometry is a big chapter in itself. I'll be covering the trigonometry part, which is used in physics. So these are mathematical tools for physics. So whatever part is required, that is being covered here, and also same goes with vector algebra. Now some students send me a message asking, is there any prerequisite? Should I know any particular topic before I join the course? Yes, there is a prerequisite. The prerequisite is you should have a lot of josh, and you should be willing to work hard. Without josh and work hard, you cannot do anything. And other than that, there's nothing required. So you just be willing to work hard. I'll take it from there. So Dhruv believed in himself and got gold medal in physics Olympiad at international level. Aditi Avnish got silver medal in chemistry Olympiads. And as we speak, there are 4 students competing from Vedantu team in Team India at the international stage. So, and again, one thing I forgot to mention, my Telegram ID is in all these slides. So if I go back a little here, so you might notice Bhavdeep Singh Sethi. I'll write it here just in case you might have missed it. So that's one word. I'll write. Where do I write? I write it here. So Bhavdeep Singh Singhh Sethi. That's all one word. So that's my Telegram ID. You can connect with me anytime and I'll be helping you. So if you need any guidance regarding your career, any courses, anything, I'm here for help. Join this channel also. You get all the useful information there. So keep up the high Josh. Josh is the key to your success. So I'll see you soon, students. Keep up the Josh.